first thing that we need to do, of course, is begin with a standard default document. And because I'm cheating in Sublime, I can now get my basic document in place. So I have my void setup and void draw, my two default functions that will be part of every sketch. After getting the void setup, void draw, your two basic functions in place, it's worth doing the standard other things that you need, such as typing in your size and getting that configured so you can decide that I want my project to be, say, 600 by 400. And I can just issue my smooth command right away. And I can even designate a default background color so that I don't accidentally forget to do it at a future date. I can just take care of that now. And if I just want to middle gray, I can just type in 128. I can test my movie, and remember in the recordings it will come up and say Command B versus Command R. If you're using processing, it's a Command R to run your movie, or click on the play button. In Sublime, it's Command B, so just keep that in mind when you're watching the recording, so that keystroke will differ. So I have now verified I have a core document structure, size, background that I wanted. Everything is working. So that's the beginning part that we want to make sure is up and running. Until you really kind of get comfortable with the coding, as comfortable as you will get, I would encourage you to hit the run button frequently, because that will allow you, as you're working, not to type in 5, 10, 15, 20, 50, 100 lines of code, hit run and go, oh, now it's broken, and you never even knew if it worked in the first place. So you start out, do a little bit of work, run, a little more work, run, a little more, and just keep back, forth, because that testing frequently will prevent you from getting so deep in typing in lines of code that then when it is broken, you are utterly and hopelessly lost as to where you could find how to fix it. So it really is a really good idea in a poorly constructed sentence. Really, really, really. It's a great idea to test often to make sure that what you have does indeed work. Now, moving on to the actual topic that we're after today, this is going to be a loop. And I'm going to use the loop to draw a rectangle. First, I'm going to draw a rectangle the hard way. So I will designate a fill color. I'm just going to designate a white fill color because I know that my background is currently middle gray. So if I say fill 255, that fills it with white. If I know I want to change this to a color eventually, I could do 255, 255, 255. So that means red, green, and blue are turned all the way on. Therefore, my color that I have selected is indeed white. So if you just specify a single number, it implies to processing that you want that number for the red, for the green, and for the blue. So that's just a shorthand way of designating it. The same way I did 128 up here, the equivalent would be 128, 128. So if I know I'm doing some version of grayscale, black, white, or a gray, I usually will just choose the number between 0 and 255 and just designate that versus typing in a red value, a green value, and a blue value. If I know I intend it to be a color at some point, but I'm starting out with black, white, or gray in the beginning, then I will use all three values, so then I am reminded that's what I need to change. So my fill color is now white. Now I can draw a rectangle. So if I draw my first rectangle at something like 20, 20, and 560, I could say 25 pixels tall. So that will now draw a rectangle, and as always, type it, test it, verify it's working. Okay, now I have a rectangle. Now if I wanted a whole sequence of rectangles, and I wanted them to change color, Actually going to make this one red to fit with where we're eventually going to get to. Now, if you copy along with the coding right now, it's probably going to, then you're going to delete a bunch of stuff. So now that you have one rectangle, I would say hold off and then just watch, because I'm going to do a whole bunch of rectangles and show you the wrong way to do it. And then I will show you how to use the loop to do it much faster and more efficiently, so then you don't go, wow, that's a highly repetitive thing. And if anytime you're doing something that's super repetitive, computers probably have a better way to do it, one, and two, the computer doesn't get bored doing it. We get hopelessly bored if we do the same thing over and 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 just keep going on for more overs. And the computer's like, yeah, I'm good. I'll do that all day. I'm happy. It's all right. So if I choose a color and I say red, draw a rectangle. Then I choose a color, I say white, and I draw a rectangle. This time I don't want to draw the rectangle there, but instead I want to draw it at, say, 35 or 45, because my first one I drew at 20. 20 plus 25 would be 45. So I draw my next one at 45, and now if I run this, I will see that I have now generated 2 stripes. That's pretty impressive now. I know you're wowed by the greatness of what that coding is, and I will continue to just impress as the afternoon wears on here. I'm going to just put a return here so I can now see the difference between pairs of stripes. So I switched the color back to red. This time, instead of being at 45, it's 45 plus another 25, so that would be 70. And now this one is going to add another 25 to it, so it'd be 95. And if I have done it correctly, we'll see that now I have 4 stripes. So you're being just knocked down by the greatness before you that this is so impressive. But as you can probably figure out, this is really tedious. But what's happening is it's revealing a pattern as we look at the code. So now that I have this pattern, so it was 70, so I had, or 95 was the last one. So then at that point it's going to be 120, and then 145. And I should have 6 stripes. Okay, I'm really bored already. This isn't a fun way to do it. There's going to be a better way to do it. Now, we could do this and continue until I get my full flag shape if I'm so inclined, but yeah, this is a crappy way to do it, and I'm not very thrilled with this. And if I decide that my red color isn't quite right, I have to go change it. Oh, I already have 3 times where I'd have to change it. That's kind of crappy, because I know this red color isn't the red I eventually want, so this is probably not going to be a really good way to go. So we can chalk this up as this is probably not the method we want to use. So I'll just comment that stuff out. I know I will be doing something with this in a little bit, but what's important to notice is if we look at these rectangle statements, the first one is at 20. The next one, all the numbers are the same except for this y value, so we're just drawing it in a new position. And we're just moving it down by 25 and by 25 and by 25. And we're going to be able to use that kind of incremental math to our advantage. Anytime we have something that's stepping in a regular and predictable and even step, we can now write a little bit of code to take care of that quite handily. So we'll come back to these lines and work with these in a little bit. Actually, I'm just going to even comment these out as well. So we'll come back to all of that, and we'll reintegrate those into it. So the basic structure that we use when we do a for loop, and I could have let Sublime complete it, but it's going to be better if I just type it in. Oh, I missed a key. All right. So the first thing I'm going to do is to draw my rectangle, and I will just fill it with that red color. Wasn't a whole lot of work to type that, so I'll just reiterate my red color. Now I know I want to draw a rectangle. I want to draw this rectangle at a specific place. Well, originally it was 20, 20, and then 560, so it's in 20 from the other side, and it has a height of 25. Now, if I were to run the code, well, one, I would get an error message because I haven't defined what this is, and we'll define that in just a moment. But what's going to happen is a for loop says, hey, why don't we just go and execute what's inside our curly braces as long as a certain condition is true. And that condition is we're constructing an integer, and we give it a name of I. Now, I could use any letter I want there. I could use Z, I could use X, C. I could even, a word. Doesn't really matter what I use. Tradition holds that it's always I, at least on your first loop within a function. Then your next one would be J. Then your next one is K, because you can't reuse the same one. So it's very common that we always start with I. So think of it as I for incremental. You can let I stand for whatever you want. Just know that tradition will be when you construct a loop, we always use I as our counter. It's keeping track of things. So we say, hey, I, you're 0. I want you to start out at 0. So the first time I execute this loop inside the curly braces, I is 0. And when I get to the end of the loop, my instructions are, well, I want I to go up by 1. And this statement says I++, which we have not looked at before. And that is the same as saying I is now equal to I plus 1. So we have seen that kind of statement before, where we say a variable is equal to the variable plus or minus a number. But when we're just adding a single amount to a number, a single 1, we're able to use a shorthand of plus plus. This holds true in nearly every programming language. So when you say a variable that is a number and you say plus plus after it, that says add 1 to it. Now there's another variation of it where you say minus minus, and that says subtract 1 from it. But right now we're going to be using plus plus. So the first time my loop executes, and what we have constructed using the word for, its full name is, it's a for loop. F-O-R, loop. Because we also can have while loops and we can have for in loops, but we're only going to use the for loop right now. The for loop is probably the most common, and in many ways, I think, for me, it has become the easiest one for me to use. So I like the for loop, but there are times where I'm forced begrudgingly to use while loops and for in loops and for each, and so there's some other variations. But it's a loop, so that means this chunk of code here that I've highlighted is going to keep running until a certain condition is no longer true. And that condition we're looking for is I less than, and I wrote in len, which is short for length, but now I could type in a number. So let's say I want to make 13 rectangles to represent 13 stripes that I'm putting on my flag. So if I say for I starting at 0, I equal to 0, while I is less than 13, do this loop. So the first time through, it will draw this rectangle. Then now, after I get to the end here, line 12, I becomes 1 more than what it was before, so it becomes 2, or it becomes 1. It starts at 0, then it becomes 1, executes again, and again, and again, and again, and again. And after I've gone through the loop 13 times, remembering that I started at 0, so after the 13th time through, I is now equal to 14. And when I is equal to 14, 14 is no longer less than 13, so then I can finally move on and execute my next line of code in my program. So the problem that you can run into with loops is you can construct a situation where it can never become untrue. So you can create an infinite loop, and the computer will be happy to do that, and eventually most programs will say, hey, we think we're stuck on an infinite loop because nothing's happened and we just are going through the same chunk of code over and over and over. You might want to do something. And often it says, hey, do you wish to abort, or do you want to quit? And that's on a good day. On a bad day, your computer gets taken down. So if you've ever been in a program, any piece of software, and suddenly it seems like it's just spinning forever and nothing's going on, and then your whole computer goes down, it probably got stuck on an infinite loop. And then usually while that's happening, it's also putting stuff into memory, and it just keeps putting more and more and more and more and more into memory until the whole thing just goes belly up. So we create a counter. We specify what is the condition that counter needs to reach to stop executing the loop. And then we specify how we want our counter to change its value. And then the lines of code inside the loop, which can be very long and complex. It doesn't just have to be 2 here. It could be 1,000 lines of code, could all execute. And then I go through and do it again, and do it again, and do it again, until my condition becomes no longer true. Once that is no longer true, then I finally get to move on to my next bit of instructions in my program. So loops are really powerful, but if you aren't careful, you create the infinite loop of doom, and then your computer could be taken down, and that would be bad. Running this, what we get to see is it makes 1 bar. Now if you notice, we were hoping it might make, say, 13 of them, because I'm going to go through this lines of code 13 times, but all I've done is draw the same rectangle on top of itself 13 times in a row. I haven't changed my value. Now what we could do, especially because I know I want this to become a vertical stripe, is I could now take this rectangle and modify its position by a certain amount and possibly relate it to what I is. So if we can come up with the appropriate kind of algorithm or math, we're able to position these boxes quite nicely. So I am going to do something that's not quite right, but just to demonstrate. So if I say 20 times I, the first time through, I is 0. So that means the Y position for my box will draw at 0. The next time through, Y is 1. 20 times 1 is 20, so we'll draw the box at 20. The next time through, it will draw it at I is now 2. 2 times 20 is 40, so on and so forth until it's no longer true. So we know that, well, that's not quite right, because I want my boxes, the boxes are 25 tall. If I'm drawing them only 20 pixels apart, they're all overlapping. That's not going to quite work. Just to demonstrate that they are indeed separate, I'm going to do them all at 30. So the first one will be at 0, then at 30, then 60, 90, etc. If I run it, you will now see 13 stripes all separated by about 5 pixels. So now I was able to fill up my screen very quickly. So if you think about some of your first programs where you had the same shape recurring a whole bunch of times across the screen, and you hand-coded it in over and over and over, this is now a much faster way to do a repetitive sequence of coding. The magic that we get to do is we put in a number that we want to be our initial starting position, and then we modify that by the kind of incremental change in value that we want. If we think about the math here, originally I drew my first one at 20. My first rectangle I drew at 20. Well, 20 plus 25 times 0. 25 times 0 is 0, therefore it's 20. The next time through, I is equal to 1. So 20 plus 25 times 1, well, that's 25, so that's 45. If I look at my second rectangle, it gave me 45. Now if I say 20 plus 25 times 2, 25 times 2 is 50, plus 20 is 70. My third rectangle was drawn at 70. And we just keep repeating that process. So what the for loop is doing by utilizing this multiplying I, which changes each time by a fixed amount, and then adding that to our initial starting point, we're able to now generate that same pattern without having to hand code over and over. Because I got through 6 here. That gave me 6, and now I have 13 stripes, but I could just as easily have 130 stripes if my project window was big enough to see it. So I could have as many stripes as I want just by changing this number, because it will just keep drawing them. If I change it to 14, I will now see that I now have 14 stripes, which isn't going to quite work because I need 13 stripes for the object I intend to produce this afternoon. So we want it to be 13. So the math that we're going to use to determine if I is an even number or an odd number is to do the modulus operation. So that's what we're going to do, and as I type it in, I will explain what this is. Essentially, what we do is we divide two numbers, and then we get to keep the remainder. We're keeping the remainder. We're not keeping, a fractional amount of something. All we're doing is just keeping that remainder. So if we take a number, divide it by 2, and there happens to be a remainder, that tells us the number is odd. If there is no remainder, when we divide by 2, we know that that number is even. So when we start counting our numbers, it goes, for our purposes, even, odd, even, odd, even, odd. 0, for our purposes, is even. 1 is odd. 2 is even. 3 is odd. So we're going to work with that. So what we can do is just simply say if I, and the way that we write out a modulus operation is we say, so if I modulus 2, and then we can find out if that results in 0. Now, we're also doing something that may have been briefly used somewhere else on a previous bit of code, but hasn't really been talked about. I've included a double equal sign. A double equal sign is different than a single equal sign. A single equal sign says, I want this to be equal to something. So a single equal sign is used to set or assign a value. When I use a double equal sign, I am now asking the question. I'm doing a comparison. Is my first value equal to the second value? So a single equal sign says, hey, I want this to become equal to whatever follows the equal sign. A double equal sign, I'm asking a question. Is my first value the same as my second value? Single equals is for setting or assigning. Double equals is for asking the question. You're comparing. Are these two values the same? So if I say I modulus 2, that means I'm dividing it and keeping the remainder. And if there's no remainder, so if 1 modulus 2, well, that's going to give me a remainder, so that's not going to work. If I say 2 modulus 2, that works out to be there's no remainder because it's even, because when I divide the numbers, it's even. my remainder is 0, so they're now equal. All right. So we're able to ask in our conditional the statement. Now, if the modulus part of the math here is hurting your brain and you're like, okay, I'm just not quite there with it, just know that it's performing division and we keep what's left. And if what's left is equal to 0, we know that we have done division on an even number. We will use this in some other code parts a little bit later in the semester, but for right now, this is a good use of it. So if my number is 0, then I want to say, so that it's an even number, I can say fill. I could have moved up that line of code, I suppose. I'll set my fill equal to red, else I can set my code equal, or my fill color equal to white. And I don't need this line of code anymore. Actually, we'll just get rid of it because it'd be distracting to leave it. So every time I loop through here, the first time 0 divided by 2, there's no remainder, so then 0 is equal to 0. Then the subsequent time 1, well, that gives me a remainder, so that's not going to work. So my color becomes white. The next time it becomes red, then white, red, white, red, white. And it just keeps going until we are done. And it's 0 through 12. That means my first and last value will both be even numbers. Therefore, my first and last stripe will be red. And I am now on my way to constructing a striped flag. So to continue on with my flag, to add in a blue box, we need to add some more. Now I'm going to just go put in red and white stripes. Now I'll put in a comment here, blue box. So I'll change my fill color to 0,0,255. And that gives me bright blue. It's not the right blue to begin with, but it's enough to get started, just like my red isn't the right color yet, but it gives me something to begin with. And then I can just simply draw a box, and I know that my starting point will be 2020 to line up with the top left corner of the red and white stripes. And then I just need to figure out how far over I want to put that box as I go to put it in. So I'm going to just guess a number. I want it to be kind of in a little more than a third size. That seemed to give it the visual representation. And height-wise, I can do the math, knowing each stripe is 125. And it turns out my blue box is supposed to cover 7 of those stripes, 7 of the 13. So then I know that works out to be the correct number there, because that now 25 goes into 175 7 times. And the first time I wrote this up when I was preparing for class, I actually said I wanted it to be 7 stripes, and I knew each stripe was 25, so I actually just did 7 times 25, and I didn't even calculate what the number, I just let it do the math for me, and that worked, and that gives me the same result, but the fixed number is 175. So eventually I went back and redid the math. If we run it, we'll see I should see a stripe and some blue box. So for adding in the stars, stars get to be white, of course, so we can just put in our white. Now you will notice that I did not put spaces after my commas, but I just as easily could. Again, white space does not matter. If you find it makes it more legible to have those spaces in, you can do that. I find that when I am busy coding, I rarely put the spaces in between my different values, but you can. Some days I try and make an effort to do so, like I put spaces in up here. Other days I resort to how I type code, which means I don't use a lot of extra spaces, so I forget to do so. All right, so our fill color is white. Well, now we need to figure out how to put this in stars. So to create the 9 rows of stars that our flag is going to require, I can now type my for loop. And again, within the same function, and draw as a function here, it's recommended that if my first loop is with I, my next loop should not use I again, it should use J, and then if I have another loop I would use K, and that would be a better way of working. So I have 9 rows that I get to draw. So that's going to draw 9 rows. Now we can, if we wanted to, we could just go and figure out and just put that in as part of it, figuring out the rows, and just draw 1 in each row right now just to see how that works. Now another way that we could do this is we could have a for loop that draws 6 stars across. Then I could have another for loop that draws 5 stars across. Then I could have a for loop that draws 6, and if you realize that now becomes that's a pattern. It's a repeating pattern. When I have a repeating pattern, I probably can use a single for loop to do it. I just have to be clever about how I organize that. And that's part of the trick or the challenge that we will get to work with on this. But just for demonstration purposes, I'll prove that we could do this. So let's see, if I inset, I'm going to go in. The flag was drawn at 20, so I need to add another, I'll try another 15 on top of that to move the star in. That's probably too much, but we'll work with that. We'll see how it works. So if my y is at 35 plus I times, just making up numbers here just to get a basic sense of placement, and we'll start to know how to set our rows apart.
Okay, that's what I was wondering.
And I typed an I instead of a J initially there because out of habit I always type I's when I'm thinking in terms of incrementing in a for loop. If we do this, we should see a bunch of boxes show up. So we'll use boxes to represent our stars because they're a little simpler to construct. A star would be a complex polygon shape, and I don't feel like trying to go through that in addition to mastering for loops. There's not a great reason why we would want to do that. But it proved we can put those in. Oh, too many. So setting a distance of 16 seems to be getting it fairly close. Gives us a starting point to work with. So we know that that would allow us to get those rectangles across. So now the trick is going to be to figure out how to do a loop, because we loop down, but we also need to loop across and draw a bunch of boxes horizontally as well. And that's the part that really starts to get kind of interesting as we're going to work our way through the project here. So with that, put in another for loop in this one. Oh, no, I want it to be K. So I have I, J, K following, and if I did another loop, it would be L. And now this number here is the one that is going to have to change, because it's either going to be 5 or it's going to be 6. So we'll just do it with 6 initially to prove that we can put these in. And then we will go and move and adjust things a little bit. So this gives us rows. And this is now going to do the boxes across the row in here, because we have a loop inside a loop. And this is where it's going to be a whole lot of fun. And our position as we're going to move it across is, if we start out and go, we know we want to be in probably about 35 because it's 20 plus about 15. And then we're going to space them apart on it. And as we put our boxes in, we're spacing them horizontally and then spacing them vertically. Remembering that J establishes the rows, so that would be in reference to the vertical lines of boxes. K is going to establish working the boxes across the screen, so that means it's referencing our X position. So that's why we have K under X, J under our Y, and running it, we can see we're starting to get kind of close. Except that we now have a few extra boxes because we have 9 rows of 6. So we're looking at, suddenly we just acquired 4 more states. But you could think about it that, if the United States ever takes and, 4 of its territories and lets them become full-fledged states, we could now add in 4 more, and then perhaps this would be the pattern, and it would make our programming job a whole lot easier. So as you go to make your flag, you can imagine that you're in some weird, future utopia where we've now acquired 4 territories as states and decided to put them onto our flag, and now we have 54 instead of an even number of 50. But if you think about it, the concept of fitting 50 stars onto the grid the way that they did, using 6, 5, 6, 5, 6, 5, 6, 5, 6, it's a pretty clever organization of the elements. So using our same even odd trick with this, what I can say is if, not phi, if J modulus 2 is equal to 0, then I get to say my row count. The term I used before was I'm going to make a variable and use it. So say number of stars per row. So initially we'll say it's 6 if it's an even. So we'll start out with 6, 0 being an even. Else, number of stars per row is equal to 5. And then I can just update this. Now, one issue that I'm going to run into here if I just run my program, I never defined what this variable that I'm using here now is. I never gave it a definition. I never told processing, hey, by the way, number of stars per row is an integer, and I'll assign its value later. It doesn't even know what it is. So when it encounters it here, it'll be like, whoa, red flag, red flag. You didn't tell me to reserve memory for that word or that variable. I'm going to freak out on you. And it'll give me that kind of bright orange at the bottom of the screen, invalid or unknown or some such message, and be like, bite me or something. But oh yeah, and don't feel bad about swearing at processing or at your computer while you're coding when it gives you error messages. That's okay. Just watch if small children are present. Make sure they're not if you're going to be really talk like a sailor day. Yeah, when we have talk like a pirate day, then we'll have to make sure that we're using all kinds of really colorful vocabulary as part of it. So if I create an integer at the beginning, number of stars per row, I could give it a starting value if I want. It wouldn't be a bad idea, so I could start it out just so we have that. It's often considered a good practice in coding to, anytime you have a variable, to give it a default or initial value so it doesn't come up as undefined. Because if you try to access a variable in some languages and you have not assigned a value to it, it will register as undefined, and undefined is not the same as 0, because number of stars per row, in this case in processing, will come up as 0 if I try to use it without giving it a value. It goes, oh, well, it's an integer, so I assume you wanted it to then start at 0 since you didn't give it a starting value. But other languages, it will come up as undefined because we never gave it a value, so then they freak out. So it's not a bad idea, but in this case we don't have to, so it's more a matter of personal preference at that point. But we know that the initial value we want it to start out at 6. So the first time through it will do 6, then it will do 5, and then it will go through this loop. The first time it will do 6, then 5, 6, 5, 6, 5. Run this, we get to see now an asymmetrical grouping of stars. You'll notice that now I have 6, 5, 6, 5, 6, 5, 6, 5, 6. So I'm close, except for the fact that I want my rows of 5 to move over. I don't want them to start at that position. I want them to be shifted over a little bit so they're kind of centered, so we get that kind of staggered look between the rows. And turns out that's a pretty easy way that we can go about doing that. And what we get to do is we get to create a value and work with it. And that value that we're going to work with, I'm going to do it again as a variable. And I will call it row offset. Now my row offset is how far I want them to be offset. Currently, everything is offset 35 to begin with. So my rows of 6, that seems to be a good amount. So I can say row offset equals 35. So the row offset is going to be for the rows of 6 at 35. We can change and set a row offset for the rows of 5. It needs to be more than that. So let's see, they are spacing themselves. So let's try 35, 45. Let's give it a row offset of 50, see how that looks. And then instead of hard coding 35 in right here, we just say row offset. So on the rows of 6, it's still at 35. On the rows of 5, it will move over to 50. So that means it's 15 more. At this point, what's going to happen is the only real change necessary to finish cleaning up my flag may be to just finesse that spacing a little bit, because I can see that the spacing isn't quite right on my rows of 5. So we need to do some adjustments because it's not as even as I would like, but it's pretty close. And one final thing that I could do is, if I don't like the black lines appearing around everything, a really easy way to get rid of that is I can put in a command, even just up at the beginning, I can say no stroke. And by saying no stroke, no capital S stroke, parenthesis, close parenthesis, semicolon, that stops putting strokes around objects. Now you can put strokes in and you can color strokes. So you can say how big you want strokes to be. You can say what color you want strokes. So you can do all of that right in your, if you want strokes, or if you don't want strokes and just want shapes, ellipses, rectangles, and the like, you put in a command like I did on my line 8, which is no stroke. That gets rid of the stroke. So then when I play and stare at my flag, we will see that now I have my flag coming up with no strokes, my 50 stars, pretty close on their spacing. It's not perfect yet, but a little bit of finessing some of the numbers down here, and I think I could get my stars to line up pretty nice, and it'd be awesome.